Hello, class, and welcome to Section 2 of Chapter 11. Today we're going to talk about arcs and chords. So hopefully you remember chords from yesterday with Miss Davis's video. Today, now we're going to talk about the relationship with the arcs to the chords and tie it in with central angles too. Alright, so I'm just going to start defining some things. So we're going to talk about two major kinds of arcs. We have minor arcs and major arcs. So a minor arc and a major arc. And this is based off our central angle. So any angle that's coming from the center of the circle. And if you'd like, also you can pause and find yourself something to draw circles with. So I kind of have this little cup. I don't always use a compass. And if you have something like a cup, a little Dixie cup, or maybe even a Pringles can, then it's really quick for you to sketch other circles that we're going to talk about. Alright, so let's start with arcs. First thing we remember is that from a circle, all the way around the circle is how many degrees? And hopefully you said to yourself 360 degrees. And then we're going to talk about parts of the circles. So anytime we talk about minor arcs have a measure that's 180 degrees or less. So M to D. They're also named with two endpoints. So less than 180 degrees, two endpoints, minor arc. Which means a major arc then is going to be any arc that's greater than 180 degrees. And we're going to name these with 3 points. That denotes the direction, so that I know I'm going from M to D all the way around this way versus M to D on the short side. So I need a little third point in there. So M, E, D. That's talking about this all the way around to here. Alright, so if you want to practice naming some arcs, we're going to draw yourself a circle. So you saw me just do that with my little cup. So hopefully you've paused and gotten something for yourself. I'm going to draw in a couple of line segments here. And I want you to, this is 23 degrees, find me the measure of arc RA. So how much does arc RA? And notice the little notation. It looks like a little arc versus a line or a ray that we've drawn in the past. So RA, how much does RA measure? And then we can even notice that it matches our central angle. So arc measures are all in degrees, and they match our central angle. So if I have 23 degrees here, 90 degrees here, then how am I going to find RA, or even angle RVA? So let's see, RN is a diameter, and all diameters have an angle measurement of 180 degrees. So on your own, you could take 180 minus 90 minus 23, and you'll have the measure of R to A. So hopefully you'll come to class with that part done. Alright, I'm going to move to the left side, and you've already picked up a comp book or a little foldable that looks like this in class today. And this is what I'm going to work on. And I'm going to end up taping it down sideways in my comp book on the left-hand side, because this piece that you don't have, you only have this that looks like this, we're going to flip it up. We're going to draw some more examples, so that's why you're going to need that cup or something to draw with. And that's actually going to be on your comp book. So hopefully you understand. You have a piece of paper, looks like this, you're folding it in half. You're going to tape it into your comp book, and then you're actually going to draw in your comp book. So I already have parts of mine done, kind of like baking, and here it is coming out of the oven. Alright, so chord measures, Chapter 11, Section 2. And we're going to start with chords, arcs, and central angles. So if you open this up, you had 3 blank circles, and they had some interesting facts here. Well, these are our theorems for this chapter. and we're going to put them into use. So you don't have everything drawn in, but if you could, go ahead and push pause. Draw in the diameters that I've drawn in and the chords that I've drawn in, and then we're going to talk about them. Okay? All right. So hopefully you're back. You have everything drawn in. I'm going to start with the one on the left-hand side. All right. First one, it says central or congruent central angles have congruent chords. Now remember, if you want to abbreviate, go ahead and abbreviate. And there are symbols for congruent, no symbols for central angles or chords. All right, so if I have a congruent central angle, these are called vertical angles. And vertical angles are congruent to each other. And angles that match open to chords that match. So MH, chord MH, is going to be congruent to chord AT. That's all that little theorem is saying. All right. If I slide over to the second one, this one says that congruent chords have congruent arcs. So let's put some letters out here so we can talk about our chords and arcs. So if AB is congruent to ED, AB chord is congruent to ED, then arc AB, this time our symbols are a little different, is congruent to arc ED. Alright, so congruent central angles have congruent chords. Now congruent chords have congruent arcs. And now we're going to tie it all together into a third one. And the third one is going to say congruent central angles. So here I have them labeled up here, A, B, C, D. So congruent central angles, AEB is congruent to CED. They're going to have congruent arcs. So in this case, arc AB is going to be congruent to arc CD or DC. All right, so we're going to put these three ideas into play, and I have 2 examples for you at the top. And if you have any questions, of course, please write them down, bring them to class, and maybe it's a question that other students have too. All right, so here's our 3 little theorems, and then we're going to put them into play. All right, you have 3 circles on the top, and 2 of those go together. So I'm going to start with these 2. Go ahead, push pause, label everything you need to label, and then push play and we'll talk about it. This is example 1. All right, you're back. This one is going to show that I have 2 congruent circles, and I have 2 chords that are congruent to each other. So chord AB is congruent to chord, I really should have put some different letters. We'll put DE. And if these 2 chords are congruent to each other, then that means their arcs are also congruent to each other. So arc AB has to be congruent to arc DE. So if you already know the ending to this story, you can push pause, work it out, and see if you get the same answer as I do. So I put in their algebra for the arc. Now it's all algebra from here. So I'm going to subtract 20 from both sides, subtract 25y from both sides, and I get y equals 4. And I did that kind of fast, so hopefully you can follow my algebra. Now if I want to go back, I can actually find how much the arcs measure. All right. The third circle is an example by itself, so example 2. This time we want to know, what does y equal? So again, we have some congruent arcs. These are still vertical angles. So congruent angles are going to have congruent arcs. So 4y equals 68. Divide by 4, and I'm going to have the value of y. And I can just plug it into the rest of my picture. All right, so that's the 3 theorems we have for chords, arcs, and central angles. Now what you need to do is open up to the back of your flat book, and you have an example that looks like this. It's going to be actually example number 3. And I'll give you a chance to push pause, write all this down, but first we need to define what it is. We can't do an example if we haven't talked about it. Okay? So on your comp book, I want you to write this. So push pause. I'll zoom out just a little. Push pause. This is where my circle came in handy. And I traced myself 2 circles on my comp book. It's actually on your book. And I have 2 theorems. The first one says, if a circle, or in a circle, if a radius is perpendicular, there's the symbol for perpendicular, to a chord, then it bisects the chord and its arcs. So here I have radius BA. It's perpendicular to chord ET. So by this theorem, that means that ES is going to be congruent to ST. And it also means that arc EA is going to be congruent to arc AT. Okay? The second one's going in reverse. It says, in a circle, if the perpendicular bisector of a chord, or if the chord is perpendicular to another line, then that chord is perpendicular to the radius. So if I have this kind of situation and I know it's a perpendicular bisector, then I can say that EA for sure is a radius. And I put in parentheses or a diameter, same thing here, because maybe it extends all the way. And then in that case I would have a diameter. So what's interesting about these 2 theorems, these back and forths, is the idea that perpendicular, Miss Davis said, what's never going to go away, I now have a right triangle. Everything that's true for right triangles is going to be applicable in all of these pictures. So Pythagorean theorem is going to play a really big role in all these things. All right, so that's how we're going to solve. Notice also, before I go on to the example, that BE and BA are both radii, and that they're going to be congruent to each other. I know when I draw it in the picture it does look a little misleading, but BA and BE, they're both radius of this circle B, and they're going to be congruent to each other. All right, so last little bit, I'm going to start this example with you, and I'm going to see if you can finish it. All right, the example says M to S is 50 units, S to T is 20 units. Find A to H. Well, right away we can see that it's perpendicular, so MT is our radius. And I'm going to go ahead and write down that MT is 50 plus 20, so it's 70 units long. Which also means that it bisects AS and SH. So from A to S to H, I'm just going to have to add them up. And the way I want to solve is I am going to put in a radius. So MA is a radius, MT is a radius. So how long is MA? Hopefully you said 70 units. And now I have 2 legs of a right triangle. So now I'm going to do a little Pythagorean theorem. So 70 squared equals 50 squared plus an unknown amount squared. And then you can solve that out. So I'm going to leave this to you. You find how long A to S is. And then from there you can find out how long A to H is. So I hope you don't struggle with that too much. I hope Pythagorean theorem's old hat to you. And when I see you in class, I'm going to be excited to see what you have as an answer. All right, so you need to finish that problem. And you need to tell me how much y equals. And if any other questions you have or it went too fast, make sure you press pause, replay, write down any questions you have, and I'll be happy to answer them in class for you tomorrow. Have a nice evening.